Hello biologists. I wanted to put together a little video for some review on transport. First off, let's just talk about the idea that molecules are constantly moving. And so if you look at the first picture here, the image on the screen, you can see that there is this orange semi-permeable membrane, and on each side there are these little water molecules. So right here is a water molecule. Okay, so these molecules are in constant motion. And as they are moving, because the membrane allows water to move past, if you were to count the water molecules, you would find that on this side there are 15, and on this side right now there are 16. And this one right here that's kind of moving through, I've put it on the 15 side. And that's actually why it's moving in that direction. Because water molecules, like all molecules, will move from high to low. So if you look right here, there are 16 molecules on the right side and there are 15 on the left. The goal of a molecule is to always reach equilibrium. Well, 15 does not equal 16, and so what will happen is for every molecule that's going to move across in this direction, then we'd end up with 16 on the other side, and you would see that then 16 would not equal 15, and so then what will happen is a molecule will move back to the other side. And this will continue to happen because the goal is always to reach equal. They want to be equal. And so once it gets to that, they will continue to move back and forth, but they'll do so at an equal rate. And so there will always be roughly 15 or 16 on each side, and they'll be moving back and forth. Well, if we scroll down and we say, okay, now we're going to add a solute. So we're going to make a solution. And if you take a look on, and let's just look at this image first right here. If you take a look, you will see that there is 25%. So let's go ahead. I'm going to just highlight this so it's a little bit easier for us to pull out. So there's 25% sodium chloride. That's salt. And over on the other side, there's 75%. If I were going to ask you to drink 25% salt water or 75% salt water, you would know easily which one has more salt in it, which one is going to taste saltier. If you look at the picture, you can also see that on the 75% sodium chloride, 75% of that volume, 75% of those molecules are salt. Therefore, only 25% are water. On the side that's 25% salt, 75% of that solution is water. And so what's going to happen here is the membrane is semi-permeable. It's selective. And in this case, it is not going to let the salt is going to be too big. It's not going to let the salt move through. And so if the salt could move through, then salt would move from 75, where it's high, to 25, where it's low. But because salt cannot move through this membrane, then the only thing that can is going to be water. And water is going to move through in an attempt to get to equilibrium. And so if you focus on the water, on this side you have 75% water, and over here you have 25% water. Well, water will move from where there's high water to where there's low water. And so these water molecules are going to start moving through this membrane. And they're going to do so pretty quickly. And so what's going to happen here is the volume is going to decrease because water molecule is going to be moving to the other side. And in the 75% chloride, the volume is going to increase because water is going to be moving in there. If I had a water balloon and I have a water balloon, I hook it up to a hose, I add water, I add water, the more water I add, the more the balloon is going to expand, right? Because it has more water. Water will move from where there's a lot of water to where there's less water because the solute cannot move. And so in this picture here, you see the outcome of osmosis. Water moved from where there was more water in a 25% sodium chloride because it's more diluted to where there was less water in a 75% salt solution where there was less water and more sodium chloride. And so water will move in that direction. Water moves from where there is high water to where there is low water. So in our lab, it looked a lot like this, okay? And in this particular situation, there's a few things that you need to know. You need to know that beaker A would be 100% water. Beaker B, well, let's just focus on beaker A. Beaker A is 100% water. How do I know that? Well, I know that because, number one, it's a hypotonic solution. I also know that because inside the little bag, right here, it says 25% sugar. That means there's 75% water. And I know that water is going to move from where there's more water. 100% water is more water than 75% water. And so I can tell that this bag has gotten bigger. If you look at the three bags, this is the biggest bag, right? Well, why is it bigger? Because it's in a hypotonic solution. It's in a solution that has more water. So if there's 100% water out here, and inside there's only 75% water, then water's going to move from the outside in, and water's going to fill it up until it reaches equilibrium. So it's going to dilute the sugar solution because sugar's too big. Sugar can't move out. And so water will continue to rush in until it gets it diluted equal to the solution. And in this case, it would not be able to do that. So water would literally continue to rush into this bag until it burst, until it popped. It'd be like putting a water balloon on the faucet and turning it on until the balloon just ruptured. Don't try that at home. Okay, so that means that the solution is hypo. Hypo means under solute. So the solution, when I talk about hypo, that means under or less solute. So less sugar. So the solution is what's around the outside of the bag. The solution that's hypotonic has less solute. Water is going to be the most hypotonic solution you can have because it's not a solution, it's just water. All right, in the middle, we have an isotonic. Iso means equal. And this is actually the goal for all cells in their solutions to reach where they're equal, where they're the same. So we would want to put our cells in an isotonic solution. The beaker then, I would know that the beaker, the solution, is 75% water, 25% sugar. How do I know that the solution around the outside? So in other words, there are going to be these little solute particles. I'll try to draw some in here just to make it a little bit simpler. So they're going to be these little solute, but the purple dots, they can't get in, but water can get out and get in. And the thing is, in an iso, it's equal. And so it's like our first drawing up here where it's almost equal. And so what's going to happen when I put a cell or a bag into an isotonic solution, what will happen is water will move in. At the same rate, water will move out. So water's going to move in, water's going to move out. So water will move in and water will move out in the same rate because it's equal. So in our egg lab, when we asked you about what was the concentration inside the egg, well, we never put the egg in a solution where it didn't gain or lose volume. And so we never put it in an isotonic solution because when the egg gained volume, that meant water was moving in, so it was in a hypotonic solution. And when the egg lost volume, it would mean that water is moving out, so it is in a hypertonic solution. And so what you have to do is you have to look at the amounts. And you can determine about what the concentration is based on the fact that in our lab, when I put the egg into pure water, it gained about 30% volume. However, when I put it in a 10% solution, it lost close to 7% volume. Well, 7 is going to be closer to 0 than 30. And so it must be closer to 10% sugar solution, but it's not 10%. And so as you went through the lab, you figured out that the solution was probably around a 7 or an 8% sugar solution based on how water was moving out at 10% and how water was moving in at pure or at the hypotonic or 0% sugar. All right, let's look at this last one. This last solution would be a scenario where you have lots of solute. So we're talking about it's hypertonic. So there's lots of salts or sugar. So in this case, we have this in a beaker, and let's say that this is 50% sugar. Okay? If it's 50% sugar in the outside solution, that means it's only 50% water also. Inside the baggie, there's 75% water. Water always moves from high to low, so 75% is greater than 50%. And so water will move from 75 to the 50%. And if we look at that then, we would realize that water is going to move out in order to dilute that really hypertonic solution. And so as water moves out, the cell is going to lose volume or lose mass, and it's going to shrink when it is in a hypertonic solution. Hyper is above or more. Solute, so solute equals the salt or the sugar or the particles, not the water. All right, so that's how a cell is going to act. When it's in a hypotonic, water from the hypotonic solution will move in, the cell will gain mass. If it's in an isotonic solution, that means the concentration of solute is the same in the cell and on the outside solution, and so water will move in and out equally, and there will be no change in volume. If a cell is placed in a hypertonic solution, water will move out in an attempt to dilute the surrounding hypertonic solution to reach equilibrium, and the cell will lose mass. I hope this helps. If you have any questions after this, please let me know.